In this video, we're going to discuss multiple linear regression, and we're going to do our calculations using Statdisk. We've discussed simple linear regression earlier, and remember that that involves one dependent variable and only one independent variable. So an example would be the braking distance of a car and the car's weight. In that scenario, the braking distance of the car is the dependent variable and the weight would be the independent variable. However, many real-world applications will involve more than two independent variables. So if we go back to the car scenario, we would have the braking distance of the car as a dependent variable, and we would have the weight, the length, and the number of cylinders of the car as independent variables. Now we are getting more data involved in calculating that braking distance. We now have three variables that we are using, and this is going to lead to a better calculation of braking distance. And that calculation of how much of our variation in braking distance is determined by those three variables is called the coefficient of determination. And in general, that increases when we use a multiple regression as opposed to a simple linear regression. Now, what that also means is that our predictions using the multiple regression equation will be more reliable. So let's look at an example. In the table given on this slide, I have systolic blood pressure, age in years, and weight in pounds of 11 men. And what we would be using this for would be to come up with an equation that relates these three variables, with systolic blood pressure being the dependent variable and the age and weight of the man being the independent variables. So we're going to use Statdisk to find the multiple regression equation relating these three variables, and we will want to round off our results to 3 places after the decimal. So let's look at the procedures that we would use in Statdisk. Remember that Statdisk comes up with the sample editor showing. And so the first thing that we would need to do would be to enter the data from our table into the sample editor. And you can see to the right here, I have done that, and I have put the systolic blood pressure in the first column, age in the second, and weight in the third column. Once we have entered the data, we would look at the top menu bar in Statdisk, and you would click Analysis. At that point, a pull-down menu appears, and you would choose Regression, Multiple Regression. The next menu, the one below, appears once you've done that. And basically all that it is asking at this point is, where did you put the data? What columns do you have data in? And so remember, we've got columns 1, 2, and 3, so you'll note that they are clicked. The other thing that you're asked in this menu is which one of those columns contains your dependent variable. Remember, we said systolic blood pressure was our dependent variable, and it is in column 1, so that is what you would choose for the dependent variable column. Statdisk generally defaults to 1 being the column containing your dependent variable, and if this is not the case in the way that you entered your data, you would need to change this little pull down menu. Once you have that allocated, you would click Evaluate at the very bottom of the screen, and your results would appear as you can see on the next slide. So basically what Statdisk does is it just takes the menu that we had earlier where we allocated our columns with the data, and it adds the results. And there's a number of things that are given here, but you'll see that I've highlighted the things that are important to us. First of all, we have a coefficient B0, a coefficient B2, and a coefficient B3. Now, I'm sure you want to know, well, why is there not a B1 coefficient? B1 is what you would have in column 1. And in our column 1, we have our systolic blood pressure, which is our dependent variable. So it is going to be the Y variable, which means that I do not have to have a coefficient for it. The other thing that you will notice is I have highlighted the coefficient of determination, and we'll talk about that on our next slide. So I want to write out my multiple regression equation, and the general form for it is y is equal to B0 plus B2x2 plus B3x3, where y is our systolic blood pressure, x2 is our age, x3 is our weight. So if I take my coefficients from the previous slide and enter them in to the appropriate B0, B2, B3, I would get the next equation. So y is equal to 30.994 plus 0.861x2 plus 0.335x3. And that is my regression equation. You fill in the b values, the x values, and the y values stay in the equation. Also notice that you cannot add these coefficients to get a single number on the right-hand side because you have an x2 and an x3, which are different. All right, so we said we would take note of the coefficient of determination, and it's 0.9768471. This means that 97.7% of the variation in systolic blood pressure is captured by the regression equation involving age and weight. Now notice that this is a high percentage. So there's very little variation in the systolic blood pressure that would be accounted for by other variables. Basically, it's 100% minus 99.7. So this means that a man's weight and age are the major determining factors for his systolic blood pressure. Now, the 97.7 also means that our predictions using this equation should be accurate. So let's look at predictions. Suppose that Jim is 53 years old and he weighs 175 pounds. We want to use the regression equation to predict what his systolic blood pressure would be. So we are given his age, which is x2, and his weight, which is x3, And we have our regression equation. So all we would do would be to substitute in 53 for x2 and 175 for x3. Then the next step would be to go through and do those multiplications, and then we would add and get a single result. So my y, or his systolic blood pressure, calculated would be 135.252. Now, systolic blood pressure is measured in a whole number, so we would round that to 135. So the prediction for Jim's systolic blood pressure would be 135.